Hello everyone, this is the review for test 1, course MAT0022, the review for test 1. And we're going to begin with number 1, asks us to evaluate 1 to the 11th power. So 1 to the power of 11, that's you multiplying 1 times itself 11 times. And no matter how many times you multiply 1 by itself, you're going to get 1. So 1 to the 11th power is 1. Number 2, write the ratio as a ratio of whole numbers using fractional notation. So to convert this 27 hours to 45 hours to a fraction, you would place the first number in the numerator, 27, and the second number in the denominator, 45. So it will become 27 over 45. However, this fraction can be reduced. You can divide both the numerator and the denominator by 9. So we can put it in simplified form. 9 can be divided into 27 3 times, and 9 can be divided into 45. 9 could be divided into 45, 5 times. That reduced fraction, and the answer to this problem would be 3/5. For number 3, find the amount of decrease and the percent decrease. So we want to fill in these two spaces. We have an original amount, and then we have a new amount. To get the amount of the decrease and to get the percent decrease, we want to look at our two values. If we start with 200 and we end up with 100, what was that amount of decrease? What is the difference? To go from 200 to 100, to get that decrease, you would subtract the larger number minus the smaller number. So 200 minus 100 gives you that decrease as 100. So this top line, the amount of the decrease would be 100. The second portion, to find the percent decrease, we take that difference, whatever the difference is. In this case, the difference was 100, and we divide by the original amount. That should be difference. So our difference divided by the original amount. The difference we calculated as 100, and the original amount was 200. When you divide 100 by 200, you'll get 0.5. Now, to change that difference to a percent, which is what we're looking for, the percent decrease, you convert this decimal to a percent. And remember, to convert a decimal to percent, you move the decimal point 2 places to the right. Fill in that empty space with a 0. So it'll be a 50% decrease. Now the next problem, we're going to divide and write the answer in simplest form again. You always want to reduce your fractions, make sure that they are in lowest terms. So 14/5 divided by 5 and 4/5. First of all, the rules for dividing fractions are that when you divide by a fraction, it's the same as multiplying by its reciprocal. So if you remember those steps for dividing by fractions, keep, change, flip, that K stands for keeping that first fraction the same. So it remains 14/15. The C stands for change. You change the operation from division to multiplication. The F stands for flip. You flip the second fraction. Now in this case, we have a mixed number, so it's not a simple flip as is. We need to convert this mixed number to an improper fraction first. So we would multiply 5 times 5 to get 25. And then to that number, we're going to add the numerator. So you add 4. The denominator stays the same, so we'll keep 5 in the denominator. Now, if we add, let me make a little bit of space here. If we add in the numerator 25 plus 4, we'll get 29 fifths. So this fraction, 5 and 4 fifths, is 29 fifths as an improper fraction. So this is the fraction that we want to flip. Flipping means moving the denominator to the numerator and moving the numerator to the denominator. Now remember, we started writing our work here. We have keeping that first fraction the same, so 14 15ths, changing our operation from division to multiplication, and then flipping the second fraction. When we flip 29 fifths, we get 5 over 29. And then we want to look to see if we can cross cancel. Are there terms that can be divided into each other to simplify the numbers that are diagonal? That helps us get to our reduced answer quicker. If we look at 14 and 29, can you think of anything that can be divided into both of those? Likely not. 7 goes into 14, 2 goes into 14, but 7 nor 2 can be divided into 29. 5 and 15, we can divide both of those numbers by 5. So let's do that. When we divide the 15 in the denominator by 5, that becomes 3. When we divide the numerator of this second fraction by 5, 5 divided by 5, this becomes 1. Now we multiply the top number times the top number. Numerator times numerator will get 14. 14 times 1. And in the denominator, 3 times 29 will give us 87. And this will be our answer, 14 over 87. So you would choose A and write your fraction as 14 over 87. Number 5, translate this question into an equation. Do not solve it and let X be the unknown number. So what percent of 20 is 10? So we're going to take each of these statements and represent it using a value. So what percent? That's the unknown. We don't know the percent. And we're told in our directions that we're going to let X represent the unknown. So what percent, that will be represented by X. Now of 20, whenever you see the word of, that means to multiply. So that means multiplication. 20, so we put the 20 there, is 10. So the word is means equals. So it equals 10. The way we write that equation is X times 20 equals 10. All right. And number 6, find the sum of 38. So we're going to add all these terms together. 38 plus 5.004 and 7.703. Notice how I placed the 38 to the left. We didn't have a decimal point. So that means the decimal point is at the end of the number, and you would fill in those spaces with zeros in order to have the same amount of values behind the decimal point, the same amount of spaces as the decimal digits. Now, in front of the 5 and the 7, we can add a 0 as well. So you just add going down. We have 7 here, 0, 7. But when you add those terms together, you should get 50.707. Now let's look at number 7. We're multiplying and simplifying our answer again. So we have 14 over 21, 3 over 16. Let's look at the terms that are diagonal to each other to see if we can reduce these fractions and get to our simplified answer quicker. If you look at the 14 and 16, both of those are even. So we know we can at least divide by 2. Is there a bigger number we can divide into both of those digits? Bigger than 2. With 4 goes into 16, but 4 doesn't go into 14. 7 goes into 14, 7 doesn't go into 16. So let's just simplify by dividing by 2. Divide the 14 and the 16 by 2. 14 divided by 2 becomes 7. 16 divided by 2 becomes 8. And here, the opposite diagonal, 3 and 21, can both be divided by 3. So 21 divided by 3 gives us 7, and 3 divided by 3 gives us 1. So now when we simplify, in the numerator, this became a 1 on the right side. So that's 1 times the 7 on the left. That gives us 7 in the numerator. In the denominator, we have 7 times 8. That gives us 56. Now 7 over 56 can be reduced even more. We can divide both of these terms by 7. And 7 divided into 7 gives us 1. 56 divided by 7 gives us 8. So 1/8 would be the answer for number 7. Number 8, assume that we're comparing the different sizes of the same brand of orange juice. We have $1.69 for 16 ounces, 69 cents for 12 ounces. Find the unit price for the 16-ounce package. To get the unit price means the price for one. So if we look at the 16-ounce package, the cost is $1.69. So we'll take that $1.69 and you want to divide it by the number of ounces you get for that price. So we're dividing it by 16. So by hand, you would write this as 16, use your division bar, and you'll put 1.69 underneath the division bar. Place that decimal point above. And then you just want to divide. 16 cannot go into 1, so it should be a 0 in front of the decimal point. 16 can be divided into 16 one time. We subtract 16 minus 16 gives us 0. Carry down our 9. Now 16 doesn't go into 9, so we're going to place another 0 above the 9 and then carry down a 0 next to the 9. 16 can be divided into 90 6 times. All right, and so we'll just leave it as 0.106. That's the price per ounce for that 16-ounce package. Now, for the price per ounce for the 12-ounce package, the cost is 69 cents for the 12 ounces. So we'll take that 0.69 and divide it by 12. So you have 12 outside the division bar, and inside we have 0.69. We're going to carry the decimal point above the line. 12 can't go into 0. 12 cannot be divided into 6, so we should put zeros in both of those spots. However, 12 can be divided into 69 5 times. That gives us 60. We want to subtract. Carry down our 9 and then our 0. 12 can be divided into 90 8 times. All right, so our answer that we get for the 12-ounce package would be 0.058. Now, the last part of the question says, which of those packages is the better buy? So which one is cheaper per ounce? The first one is 0.106. That's about 10 cents per ounce or 11 cents per ounce. The second one is 0.058. That's about 6 cents per ounce. So the cheaper package per ounce would be the 12-ounce package, and that will be the better buy. Number 9, write this percent as a decimal. To change a percent to a decimal, remember you just move the decimal 2 places to the left. So 1, 2, that would give us 0.768 or 0.768. Number 10, we want to round 254 to the nearest 10. Now, to round to the nearest 10, we need to be able to determine which of those digits is in the tens place. The 4 is in the ones place, 5 is in the tens, 2 is in the hundreds. So we'll underline the digit in the tens place, draw the arrow to the neighbor. So we're asking ourselves, what does that neighbor do for the digit that's underlined? Do we round up or do we stay the same? You round up if this neighbor that you're pointing to with the arrow is 5 or higher. If that number is less than 5, you would stay the same. Since this number is less than 5, we stay the same and we put zeros behind the digit. So it should be 250. Round it to the nearest tens place. Let's look at number 11. We're multiplying these three fractions together. And just like with the previous problems, we want to look at the terms that are diagonal to each other to see if we can cross cancel and get to our simplified answer quicker. So 11 and 2, can we divide both of those numbers by anything? 11 and 22, 1 and 22. 11 and 22, we can divide both of those terms by 11. So we're going to divide 11 into 11, you get 1, and 22, we divide by 11, we'll get 2. The opposite diagonal, we have 3 and 2, that can't be simplified any further. 3 and 15, however, we can divide both of those terms by 3. So 3 divided by 3 gives us 1, and 15 divided by 3 gives us 5. So now multiplying the terms in the numerator, 1 times 1 times 1 will get 1 in the numerator. In the denominator, 5 times 2 times 2 gives us 20. 1/20th is our answer. For number 12, we're going to perform the indicated operation. 3 divided by 7/12. Now, remember the steps for dividing fractions: the keep, change, flip. When you have a whole number, you want to make the whole number a fraction by placing it over 1. So we would keep that first fraction the same, 3 over 1. We would change the operation from division to multiplication, and we'd flip the second fraction, 12/7, and then multiply. So we're going to go ahead and multiply the numerator times the numerator, the denominator times the denominator, because we can't cross cancel anything. There isn't numbers that we can divide into 12 and 1 and 3 and 7. So numerator times numerator, 3 times 12 will get 36. And the denominator, 1 times 7, will get 7. This is our answer. For number 13, the ratio of weight of an object on planet A to the weight of that same object on planet B is 100 to 3. So we're going to go ahead and write that ratio 100 to 3 as a fraction. And recall 100 applies to the weight of planet A, because we're comparing planet A to planet B in that order. So A applies to 100, just put A here, and planet B applies to 3. If an elephant weighs 2,900 pounds on planet A, find the elephant's weight on planet B. So I'm putting an equal sign here because we're going to write a comparison using planet A over planet B, that same order, the number for planet A in the numerator and the number for planet B in the denominator. Based on this second statement, if an elephant weighs 2,900 pounds on planet A, since we have planet A in the numerator of the first fraction, we're going to put planet A, which is 2,900 pounds, in the numerator of the second fraction. Now we want to find the weight of that animal on planet B, so we'll put X here. To solve, we need to cross multiply. This was planet B, but times the 3. All right, so that B and A are there just to remind us how to position. Let me erase them now because they are not going to be included when we cross multiply to solve this problem. We're going to multiply the terms that are diagonal to each other. So 3 times 2900 and 100 times x. We'll put an equal sign between them. So 100 times x gives us 100x. 3 times 2,900 gives us 8,700. We want to divide both sides of this equation by 100 to solve, and we'll get x equals 87. All right, so for part 1, we should have x equals 87. That represents the weight on planet B. So planet B. Type an integer or decimal rounded, so we've already did that. Part A says for number 1, we're looking at our response that we just put in here, this 87. It represented the weight of the planets, the elephants, or pounds. It represented pounds, 87 pounds. Number 14, write the fraction as a percent. To write a fraction as a percent, you first want to divide to get the decimal. After you get the decimal, you're going to move the decimal 2 places to the right. All right, so when we divide to get the decimal, we have 8 outside the fraction bar, 5 inside. 8 cannot be divided into 5, so we should put a 0 above, add our decimal point, and add a 0. 8 can be divided into 50 though, right? We can make that division. 8 can go into 50. How many times without going over is what our goal is. All right. It could be divided into that number 6 times. And 6 times 8 is 48. We're going to subtract 50 minus 48 will give us 2. We carry down the 0 here. 8 can be divided into 20 2 times. 2 times 8 gives us 16. We want to subtract and carry down our 4, and then a 0 next to 4. So 8 can be divided into 40 5 times. That decimal point should be here. So 0.625 is that first step. Remember, we divided to get the decimal. So 0.625. Next, you want to move the decimal 2 places right. So we'll start in front of the 6 and move our decimal 2 places to the right. We should get 62.5%. For number 15, we have 2 fractions, 7/10 minus 7/15. We need to get common denominators in order to subtract these 2 fractions. So we have to find the least common multiple between the 2 denominators that we currently have, 10 and 15. So we would list multiples of 10 and 15, find the smallest multiple that we have in common. So we list multiples of 15, we'd have 15, 30, there we go. 30 is also a multiple of 10. So we can rewrite both of these denominators so that they have a denominator of 30. All right, let's make a little bit of space here. We want to rewrite both of those fractions so that they have denominators that are equivalent. In this case, that equivalent denominator is going to be 30. So for this top fraction, in order to make 10 30, we have to multiply by 3. Now, because we're multiplying by 3 in the denominator, we must also multiply 7 times 3 in the numerator. So that'll become 21. For the bottom fraction, we want to make our 15 a 30. What do we multiply 15 by to get 30? That's times 2. So we got to multiply the numerator. 7 times 2 gives us 14. Now we can subtract. So let's look at it closer here. We have 29 over 30 minus 14 over 30. And you want to keep your denominator the same. Keep 30 in the denominator. And in the numerator, we have 21 minus 14. That would give us 7. So our answer is 7/30. For number 16, we want to write this fraction as a decimal, and if necessary, round to the nearest hundredth. That's 3 places after the decimal point. So we're dividing 59 by 90. We should have 90 outside our fraction bar, 59 inside. And 59 cannot be divided, well, 90 cannot be divided into 59. So we needed to add that decimal point there. Put it above the line as well. And since 90 could not go into 59, you're going to go ahead and put that 0 in front of the decimal point. Now, how many times can 90 be divided into 590? That would be 6 times. 6 times 90 gives us 540. We want to subtract. 0 minus 0, 9 minus 4 gives us 5, and these 5s cancel. Now, 90 into 50, no, but we want to go ahead and add a 0 next to this digit. So we went ahead and subtract. 90 can be divided into 500. How many times without going over? That'll be 90 times, well, we saw that 90 times 6 was 540. That's too big. So 90 times 5. That'll give us 450. We want to subtract 500 minus 450. We'll get 50. Carry down the 0. You see how it's going to repeat again. We'll put another 5. Now, the directions say round to the nearest hundredth. That's 3 places after the decimal, or 2 places, not 3 places, 2 places after the decimal point. So we have 0.655. That second place after the decimal point would be the first 5 next to the 6. Now we look at our neighbor to determine what happens with this 5. Will it stay the same or will it round up? Since the neighbor is 5 or higher, we would round up. So this should be 6 and 6. We would round up to 0.66. Now that'll be part 1 of the practice test. We'll continue the second half in the second part of this video.